Last week you learned about curved mirrors, and we looked specifically at concave mirrors where the curve curves in, and they're also called converging mirrors, and that is because as rays of light come in and reflect off of the curved mirror, the reflected rays come together at this point F, which is called the focus or the focal point. We're going to take a look at how to draw ray diagrams, which we can see here, to determine what the image is going to look like of a particular object that is placed in front of a mirror. So what we can see when we look at this diagram is that when we have a ray of light that is traveling parallel to the principal axis, so remember this line that comes through the center of the curved mirror. So this isn't something that's actually here, but this line here, and this is where the bottom of the object would be placed. And it's called the principal axis. So we can see that all of these incident rays would be parallel to a principal axis. So when we have a ray of light traveling parallel to a principal axis, once it hits the mirror and reflects, it then is going to go through the F. So we can draw that ray on any particular image. So if I have an object here, what I'm looking for is a ray of light, an incident ray that is coming in at the very top of the object, and it is parallel to the principal axis. And as that ray hits the mirror, from there it's going to change direction as it's reflected, and the reflected ray comes right through F. What we can also see is that if we had any of these reversed, so instead of incident ray and reflected ray, my incident ray was going through F. Once it hits the mirror, it's going to reflect and travel parallel to the principal axis. So that is the second ray that I can draw in, where the ray of light lines up with the top of the object and goes through F until it hits the mirror, and at that point it's going to change direction as it's reflected, and the reflected ray is going to travel so that it is parallel to the principal axis. Now what we can see here is both of the incident rays intersect at the top of the object, and when the reflected rays intersect, that is where we're going to see the top of the image that is being reflected. So we always have the bottom of our object or image touching the principal axis, and where the rays intersect, that is either if they're incident rays, that's the top of the object, and if we have reflected rays, that is the top of the image. So in this case, this image, because the intersection of the reflected rays is underneath the principal axis, this image is actually inverted or upside down compared to the object. And you saw this last week as you did the lab with the optical benches, where the flame from the candle was often upside down. So we're just going to take a look at drawing these. So you're going to have an assignment to work on, and you can either work pencil and paper, or I'm also going to load it into your OneNote. And what you can do from there is take a screenshot of each of the diagrams you need to complete here, and then you can work. And you can work in here and use the ruler. So the first ray that we're going to draw, and this makes it nice and easy to get it exactly parallel because we can see the degrees on the ruler. So for parallel, we want it at 0. We're going to line it up with the top of the object, and then we're going to draw our incident ray that is going straight until it hits the mirror. And then from there, that is then going to line up so that it goes through F. And it may take a little bit of practice, so I haven't done this on here before, of where exactly you have to hold the ruler so that you are continuing from the exact point that the mirror was hit and going through the center of F. Okay, so that looks like I need it to be a bit further up over here. That's not quite going through the very center of F, although this part worked out well. So I'm just going to undo that and move this up a little bit and see how that works. Okay, that one didn't work great either. This is where pencil and paper may actually work a bit better, although perhaps you have some better skills than I do on this. Okay, that's not too bad, and we want to extend it all the way. And then the second ray of light that we're going to draw, that one does the reverse. It goes from the top of the object and goes through F first until it hits the mirror. Okay, so it looks like part of the problem is we can't do half a degree, which is probably what would be needed here. And then once we hit the mirror, we're going to turn it once again so it's parallel, so it's 0 degrees, and then we want to line it up so that we continue exactly from where the mirror was hit. So this is our second ray. So we have our incident ray coming in, the reflected ray coming out, and then also for the first one, incident ray, reflected ray. So the point where the reflected rays intersect is going to be where the top of the image is, and the bottom is always going to be, at the principal axis. So we can see for the object, the bottom is at the principal axis, and then the top is where the incident rays intersect. For the image that is formed, we're going to have the reverse in this case. So we still have the principal axis is where the bottom is, and then the top, so the top of the arrow is where the reflected rays meet. So this is going to be the image. And then if you take a ruler here and measure, so the height here looks to be about 1 centimeter. And here it's a little under, looks like 0.9 centimeters. So what I can see in terms of the size, so we use something called SALT to describe the image. So S stands for size, and in this case it is smaller. It's not a whole lot smaller, but it's a little bit smaller. A stands for attitude, and that just has to do whether it is the same way as the same direction as the object, which would be right side up, or if it's upside down or inverted, which in this case it is. And then we talk about the location. So in this case, I don't have C on this diagram. If I had C listed, I could also use that in relation to the position of the image. So if I had C over here, I could say that the image is in between C and F, but here all I have is F. So I'm going to say that it is beyond F. So here I could say between F and the mirror if it was in this section. Because it's in this section, I'm going to say beyond F. And then the last would be type, and type, it can either be real or virtual. So anytime we have reflected rays that intersect, we have a real image. And you'll see in a moment when we look at a convex mirror, what a virtual image will look like. A concave mirror can produce real images, it can produce a virtual image, and it can also produce no image. So it just depends on where the object is located in relationship to F and to C, which is twice what F is. So if I could measure the distance from here to here, that again would be where C would be. Remember, that's the center of curvature, or the center of what the circle would be if we followed this around for a full circle. So once you have that, you can save that and put that back into OneNote if you want to work in here. So convex mirrors, these we haven't talked about, but they just, the curve goes in the opposite direction to concave. These are also called diverging mirrors, and it's because the reflected rays actually diverge or move away from one another. So in concave mirrors, converging, the reflected rays come together at the point of F. So F and C are on the opposite side of the mirror in this case, because if we were to continue around and make this a circle, then the center of curvature would be over there. And F is half that distance. So over here, what we see is that the diverging happens as though it was coming from F. So we're going to use that as we do our ray diagram. So we still have the same rules, except that F is on this side. So we have one ray that goes parallel to the principal axis. When it hits the mirror, it's going to line up with F, but it's actually moving in this direction. The reflected ray, so remember, it's reflecting off of the mirror. So it needs to be coming out the same side as the mirror. And the next one lines up with F, but we don't draw all the way to F. We stop once we hit the mirror, and then from there, it's going to be parallel to the principal axis. So we have the same rules once again. So I'll take a look at this one, and we'll take a screenshot of that. Oops. So once again, our first ray of light, we're going to go parallel. So we want 0 degrees. I'm going to line up with the top of the object and draw a straight line until we hit the mirror. Then from that point, it's going to reflect. The way it reflects is that it lines up with F. Okay, that's fairly decent. And then it is moving out from the mirror. So we have our incident ray coming in and our reflected ray going out. And then our next ray is once again coming across the top of the object. We're going to line up with F, but we're not actually going to go through F. So we're only going to go until we hit the mirror, because once a ray of light hits the mirror, it is going to reflect. So from that point, what's going to happen is this is going to line up with the principal axis. So if you're using the iPad to do this, then we want 0 degrees on our ruler. And the reflected ray is going to come out here. So incident ray coming into the mirror, reflected ray coming out. Now what we see is our reflected rays are diverging from one another. They're moving away. So what we do to figure out where our image is going to be is we extend our reflected rays backwards, and we do a dotted line anytime we are extending backwards, because these don't actually exist. And the point where we will see our image is going to be where those extended lines of the reflected rays meet, which is over here. So always the bottom of the object and the image is on the principal axis. And in this case, the reason we draw an arrow is so we can tell where that arrow side is. So here, where the incident rays intersect, and so where the extended reflected rays intersect, that's where the top of the arrow is going to be. In this case, I don't need to actually measure. I can very clearly see that the size is smaller for the image. It is located behind the mirror. So this is an image that we would see in the mirror. It's not something that actually exists. And apparently I don't know how to spell salt. So A was the attitude, and this is upright or right side up. And then the type. So anytime we have to extend our reflected rays back, and it's the extension of the reflected rays that meet, we are going to have a virtual image. So the other thing that tells us it's a virtual image is that it is behind the mirror. So when we have a mirror, light rays will reflect off of the mirror. And so anything that is produced, any image produced in front of the mirror is a real image. So you guys saw when you had the piece of paper in that you were holding with the candle that you could actually see an image on the paper. For some of them, there was no image on the paper, but when you looked into the mirror, you could see an image in the mirror. So anything that's being made in the mirror, your brain is assuming that these reflected rays came from back here, which is in the mirror. So you're seeing it in the mirror, but it's not really something that is actually physically there, like the images we saw on the piece of paper. So a mirror, if it creates an image in front of it, that's going to be a real image. If it creates it behind the mirror, then that image doesn't actually exist. It is a virtual image. So in your assignment, you are going to be practicing drawing these ray diagrams. So once again, the rules are the exact same for both concave and convex. So you have one ray that comes parallel to the principal axis across the top of the object until you hit the mirror. And then you line up with F, whether F is over here for a concave mirror or behind the mirror for convex. You line up with F and your reflected ray is coming out from the mirror. Your second ray lines up with the top of the object and F. So if F is in front of here, you go through until you hit the mirror. With a convex mirror, you line up with F, but you only go once again until you hit the mirror. And then from there, from the mirror, our reflected ray is going to come parallel to the principal axis. Where the reflected rays intersect is where your image is. If reflected rays are diverging and don't intersect, then we extend them backwards, and where the extension of the reflected rays intersect is where the image will be. And then size, attitude, location, and type are what we use to describe the images produced.